Geometric sequences. So we did arithmetic. Arithmetic is you're just adding or subtracting the same number. Geometric, you are multiplying or dividing by the same number. Okay? So a geometric sequence is a sequence in which each term after the first term is the product, because we are multiplying, of the preceding term and the common ratio. Common ratio usually we just say log. Okay, so example 1 says determine the common ratio and find the three terms in each sequence. Like we did yesterday where we take the second term minus the first term, figure out the difference. Here we're taking the second term divided by the first term to figure the common ratio. So if I take the second term, 1/2 negative, divided by the first term, 1, I just get negative half. So that would be our common ratio. And we can double check ourselves because if I take 1 times negative half, I get negative half. If I take negative half times negative half, I get. Does this make sense?
Yeah.
Okay, how do we find the next term?
Add negative 1/2 times negative 1/2.
There we go. 1/4 times negative half. Oh, you can do those in your head. Don't do any calculator.
Negative 1/8
Okay, how do we find the next one?
times negative 1/2.
Which would be, don't do your calculator.
Yeah, 160.
What's our next one? Don't do another calculator.
Negative 132. I have to.
Me too. Just to check.
Once. All you have to do is take 1 times negative 1 and then 8 times 2.
You want me to see the calculator?
Alright, how are we going to find the common ratio on the...
No. I don't know.
Okay, what's our middle term for second term?
Negative 3 plus 3.
Okay. What's our first term?
R minus 1.
So all we do is divide. Right? Second term divided by first term.
R's cancel, don't they?
No, right, that's correct.
No, we lost 3. Oh,
Oh, it's not even on one. All you have to do is on this way. Factor out. Okay, factor out the top. 3. So if I factor out 3, I have a negative R and a plus 3. So if I factor out a negative 3, I just change the signs. Right?
Sure.
So I have R minus, oops, not. See what I'm saying? 1. So then the R minus 1, R minus 1 cancel out. So negative 3 would be R.
So it's 3?
Negative 3. Well, you just think about it. Let's think. How can I get from where can I multiply R minus 1 to get negative 3R plus 3? If I take R times negative 3, I get negative 3R. If I take negative 1 times negative 3, I get plus 3. Right? Yeah. Alright, so then how do we get our next term? How do I get the fourth term?
Take that 28, so it's negative 27 plus 27.
Negative 27 R plus 27. Yeah. Okay, how do we get the fifth term then?
Negative.
It's because negative times negative. Oops, 81 R.
81. Then
What is it?
243.
243? I'll take your word for it. And this one would be negative. This would be a plus 43. Any questions, comments on that? Alright. And then just like we did yesterday with the equivalent and figure out if we want, instead of just keep going multiplying by the ratio, we want a specific term. We can use our formula here. Ooh. That's an exponent. A minus 1 is a whole exponent. So example 2 says find the approximation for the 23rd term in the sequence. Before we can do that, we have to find the common ratio. How do we find the common ratio?
take something like 9 times Divided by hour versus
Yeah. What would we get?
negative 0.7.
Negative 0.7 would be our R. So then we just plug in our formula. A sub n, so we're saying A of the 23rd term, is equal to A sub 1, so the first term, 256, times the common ratio, negative 0.7, to the epsilon n minus 1. Well, n is 23, so 23 minus 1 is 22. So family order of operation, are you going to multiply or are you going to do epsilon? Excellent.
Negative 1,000,914,180.
Well, it's just find an approximation.
So negative
Would not be
0.1.
Negative 0.1.
No, it's not negative.
Yeah,
No.
yeah.
Because you did.
Because I'm taking a negative 0.7 times it's on 22 times, it's an even number, it's going to get positive, because that'd be an even number of negatives.
No.
So that's a limit.
Negative 0.7.
In parentheses. 2 to the 23rd.
Negative 0.7. Yeah, 27.
7 parentheses in the formula.
Yeah.
But this is saying you're taking all that to the 22nd.
0.1. There.
Yes, I agree. Not negative, because it's to a even power. Just say even powers are always positive, no matter what. Odd powers, if you have an odd number, or a negative number, is going to be negative.
No, even numbers.
Alright, geometric means, just like we had arithmetic means, geometric means are the numbers in between the terms. So it's the same idea as what we did yesterday when we were looking for geometric means. So we're looking for two geometric means between these two numbers. So that means A sub 1 is 48. We're looking for the next two. So we don't know A2 and A3, but A4 is going to be negative 750. So it's like yesterday. Alright, so then what I would do is I would say, we know A sub 4 is equal to, and I'm using this formula again, is equal to the first one times our common ratio, which we don't know, R, to the n minus 1 power. So it's 4 minus 1 is going to be power of 3.
So, can you divide by 48?
And yes.
Negative 15.65.
And you're right, so we're going to have to take the third row to get rid of that third power there.
Negative 2.5.
Did I leave you there, Caitlin?
Yeah,
Or did I leave you?
it's okay. I think if I do this right,
Question. So why is it not negative?
I got it.
Is this one negative?
Yeah.
Because we have an odd power, 3. Not even.
But if you have the fourth row of that.
The fourth row, you couldn't do it because then you get 9.
So this is
It's like taking the square root of a negative would teach you 9, taking the fourth root of a negative would teach you 9.
But not the third row.
Because I can take a negative times negative times negative to get a negative. I can't take a positive times positive to get a negative. Alright, so we're almost done. Now we can figure out what A sub 2 is. So we'll figure out A sub 2. Oh, not quite done yet. We have to put it in, okay, we're going to use that same formula. So the first term,
Did you just take 48 times?
take this negative 0.25 to the n minus 1, or it would be 1, because 2 minus 1 is 1.
Negative 1.
And then how about the next one?
300.
Yeah, okay. So this is what we're going to do. Alright, so we'll
So A2 is positive.
Yep,
Oops.
because
Really
we,
negative, that's a negative.
because we have 48 times negative 42 going to the second power. So it's even power, so it's no negative power. Negative is negative.
So then it could be like A2 and A2 don't have to be between 48 and 716.
Well, since I'm taking it times a negative number, every other one is going to be positive, every other one is going to be negative. Because a negative times a negative is positive, times another negative would be negative, times another negative would be positive. It's just going to alter. Does that make sense? All right, and then the series is again the sum. So we're adding all these different terms of the sequence.
Are you recording this? Is there anyone else in this?
Hi, Aaron.
Aaron!
Did you record yesterday?
No. All right, so for this one, asking us to find some of the first 10 terms of this series. So I know that n is going to be 10 in this case. We're going to have to figure out what r is before we can plug it into our formula. How are we going to figure out what r is?
Hold on.
Hey,
How'd you get n is 10?
Because they're asking to find the first 10.
Oh.
So how are we going to figure out what r is?
You know, I'll take negative 48 times this.
Don't have times.
Divide by
That's the ratio which is divided.
negative 3.
So then we can just plug into our formula here. The sum of the first 10 terms, first term is 16 minus the first term 16 times r to the 10th power 1 minus negative 3.
So no, I don't think that's right. 236,196.
You got it.
Yay.
Although I have a negative.
2 through 6 to
You do have a negative? I do have a negative. Negative 236,000.
I can put it in parentheses.
I have 236,000.
Oh, I may put it in my columns. So 3 to
So I get a positive.
negative 16 plus 16 divided by 4. No, negative.
See, come and watch.
Okay, let's see. So negative 3 to the 10th power is
Oh.
going to be a positive, right?
Oh.
Oh.
You snide it? What?
Not sure what you're saying.
No. Okay. How did I get the same number as you? But I never took 16 minus 16. Is that...
We're not taking 16 minus 16. You're taking negative 16 times this huge number.
Why isn't there a 16 in front of it?
Because in our formula, we've got the first term minus the first term times the ratio.
Minus 16 times negative 3 to the 10.
Instead of trying to plug it in your calculator, I would just think order of operations. It tells us to do exponents first. So this turns into,
See, that's what it is. I still got the same number as you, just not negative, because I never took 16 minus 16, but I didn't do that. I just had 16 times negative 3 to the 10th. That's all I got.
okay. But then we would, yeah, so it is this, and then we would multiply, and then we would subtract, and then we divide by 4.
Oh, so what is R and what is N?
R is a ratio,
Ratio.
so what do you take times each number to get there? In order to figure that out, you take one of the terms divided by the little bracket before it, so in this case R is negative 3. so n is just, n is the number of terms. In this case, 10 or 10 terms. N is number.
Yes, so there's the sum.
And this is the sum. So if we were gonna find the first 10 numbers in this series and add them all up, they would add up to this. Does that make sense? Okay, because they gave us the first 4, we kept going and add up all those numbers. We would end up with. Okay, questions, comments?